Hey everyone, in this video I will show you how to set up and use the HC-SR04 Ultrasonic Sensor with a Raspberry Pi Pico running CircuitPython. I'll then show you how to use the distance values you collect from the sensor to control a servo motor. But first, a little background. As I mentioned, I'll be using CircuitPython to program the Raspberry Pi Pico. CircuitPython is basically a slimmed down version of Python that has been optimized to work with microcontroller boards, like the Pi Pico or Adafruit's Circuit Playground. As you'll see later, it also makes it really easy to interact with motors and a lot of sensors from Adafruit's website. Now, for the HC-SR04 sensor itself. This thing basically works in the same way that echolocation works for a dolphin. After being triggered, it sends out an ultrasonic pulse, and that sound wave then bounces off some object in front of the sensor and returns to the sensor. Then, the sensor measures the amount of time it took for the sound wave to bounce off the object and return. And since we know the speed of sound, we can then divide the time value in half and calculate the distance to the object. If you want to get a little more precise, you can take into account temperature, which affects the speed of sound in air, and use that more precise speed of sound value to calculate distance. Okay, with that said, here's a circuit schematic I've drawn. Overall, it's pretty simple. The Raspberry Pi Pico is powered by 3.3 volts and is connected to a common ground with the ultrasonic sensor. The ultrasonic sensor is powered by 5 volts, and its trig and echo pins are connected to GP14 and 15. The only thing of note here is the voltage divider between the echo output on the sensor and the GP15 pin on the Raspberry Pi Pico. This is here to reduce the voltage from 5 volts to something the Raspberry Pi Pico can handle, which happens to be about 3 volts. Without the voltage divider, the Raspberry Pi Pico would get damaged over time. Here is the code for the HC-SR04 Distance Sensor. Normally, if you were to write code for the sensor in Python or MicroPython, you'd have to manually trigger the sensor, detect when the sonic pulse starts and ends, and record time values. However, as I said before, CircuitPython makes this process a whole lot easier. You simply have to download the Adafruit HC-SR04 library and call a function. That's what you're seeing right here. In the description of this video, I'll link the page on the Adafruit website that tells you how to do this. And for comparison, here's a script I wrote in MicroPython that does the exact same thing. Notice that it's twice as long and much more complex. Alright, here is the distance sensor in action. Here I am moving a ruler back and forth to get a few different distance values. And if we look at the Python shell, we can see the output in inches. And as a note, the distance sensor does have a range of about 200 to 400 centimeters. Now that we've got the distance sensor working, we can have some fun with it. And here, the options are truly endless. You could make anything from an obstacle-avoiding robot to a proximity alarm or even a backup sensor on your car. I haven't done any of that, but I have used the distance sensor output value as a control for a 180-degree servo motor. For example, if the object is closer than 2 inches, the servo will remain at 0 degrees. If it's 12 inches or farther, the servo will go to its maximum 180 degrees. And any distance within that 10-inch window will be proportionally mapped to a degree between 0 and 180. Here's the code. At the top, you can see I've imported another Adafruit library, this time for motors. And so, this program works by first taking a measurement and converting it to inches. Then, that value between 2 and 12 inches is proportionally mapped to an angle value between 180 degrees and 0. That angle value is given to the servo, and this repeats every 0.2 of a second. And here is that circuit in action. For reference, the servo is currently at its 0 degree position. It is now at its 180 degree position. As I move my hand closer, you can see the servo respond by moving its arm closer to 0. And as I move it farther, it goes towards 180 degrees. Closer, back and forth. So yeah, that's the ultrasonic distance sensor in action. And as you've seen, CircuitPython makes it super easy to work with. With that said, as a quick reference, here's the Adafruit website. And if I go here, I can see all the sensors and devices that are compatible with CircuitPython. And for each, it's basically the same thing. You import the relevant libraries and you can work with them really easily. There's a lot of accelerometers, temperature sensors, humidity sensors, and basically everything you can think of. So yeah, thanks for watching, and if you have any questions, feel free to message me or leave a comment.